Lesson 34-2 is going to talk about the volume of prisms and cylinders. So that's what we're going to be working on today in our Springboard book, starting on page 500. Okay, so we're not going to really deal too much with the context of this situation, but we're going to be looking at this hexagonal pyramid here, this six-sided figure for our base with a height h. Okay, so name the figure that's described in the container. Well, I kind of just did that for us. Okay, we know since our base is a hexagon, we have a hexagonal. And since our sides are all rectangulars, we know that is a type of prism. So this is a hexagonal prism that we have here. Okay. Now, to find the area of any prism, here is the formula that we're going to be using today. Okay, it's the volume is equal to the area of the base times the height. So remember, big B always stands for the area of the base. Let me do this. Big B equals. Okay, so it's important to know that kind of notation. Big B, area of the base times the height. That will give us the volume of any prism. Okay, so we know that our base is a hexagon, so I just drew a hexagon here. They want us to suppose, okay, the radius of the container is 2 inches and the height is 4. Let me go back here. We know the height is 4 and they're saying the radius, so if we start at the center and go out, would be 2. So if I just draw this on a flat figure here, a flat base, okay, draw that in. We know that's 2. We need to figure out what's the area of this hexagon. So remember, when we're finding area of these regular figures, we think of that as like our one little triangle there. And we need to find the apothem. So we drop that perpendicular line, figure out the apothem. So let's just look at just that triangle. Okay. If we have 6 figures, we know our central angle here should be 60 because it's 360 divided by the 6 sides. So that way, when I drop my perpendicular apothem, maybe I'll just look at it as just the right triangle here. We know that that's going to change this to 30 degrees. So we have a 30, 60, 90 triangle with the hypotenuse being 2. Okay, so if the hypotenuse is 2, that makes our short leg 1 and our long leg root 3, 1 root 3, right? So there is our apothem. So right now what I'm calculating again is big B, the area of my base. Remember that's 1/2. Our perimeter, now we got to calculate the perimeter. So remember if this is 1 and 1, that makes each side here 2. 2, 2, 2, 2, 2. So 2 times 6 would make our perimeter 12, right? So we have 1/2 our apothem times our perimeter, which we just figured out was 12. Okay, that's the area of our base. Okay, so if we have 1/2 of 12, so let's like say 6, so the area of our base would be 6 root 3. And I'm just keeping everything right now in terms of the radical. I'm getting the exact volume here. So then to find the actual volume of this prism, we would take our area of our base. We just figured that out was 6 root 3. And we multiply times the height. Now, if we go back to this, they told us in the beginning the height was 4. So area of the base times the height. So 6 times 4, that would give us 24 root 3. We have inches cubed. Now, for volume, we're always going to use cubic units. So just make sure you keep that kind of notation there. Okay, so again, it's important to remember how to find the area of the base. So you're going to have all different types of figures here. You could have triangles, rectangles, or any of those regular polygons. Make sure you remember how to find the area of the base, and then we times it by the height. That gives us our volume. Okay, so I'm going to have you guys try this volume of this prism that I have below here. Now, again, this is not from your book. I just kind of added it in just to give you guys an extra example to see. Move this over a little bit. Okay, so I want you guys to find the volume of this trapezoidal base. So again, the volume is the area of the base times the height. So if it's a trapezoidal prism, you know your base is a trapezoid. So if you remember, how do we find the area of a trapezoid? You gotta remember your formula. Find the area of your base, times it by the height. So go ahead and try this one right now. All right. So the answer you should have gotten was 820.8 meters cubed. Now, if you have something close to that, we're good. Remember, to find the area of a trapezoid, we would take 1/2 our height times the sum of our bases. So 1/2 of 5.7. Okay, times that by the sum of our bases, so 6 plus 18. There's your area of your base, times that by the height. Now remember, the height is always the distance that connects your two parallel bases. So in this picture, our height was 18. So that's how you would get 820.8. Okay. We're going to move on now to cylinders. So remember, we have two types of cylinders. A right cylinder, which your height would just be this distance here that connects your two parallel bases. Or remember, if it's oblique, that means that cylinder's on a slant. So that height, we would kind of write off to the side. Because remember, our height is always perpendicular. Perpendicular distance that connects base to base. Okay, so let's talk about a cylinder here. If I draw one in really quick. I don't think I can put them in on my... No, I didn't think so. So let's just draw in a cylinder. We have a circular base, our height, and then our circular base on the bottom. That's pretty good. Okay. So if we remember, what was the cross section in a cylinder? So if we took a plane and cut it through that cylinder, what did we know about every cross section of a cylinder? Okay. Well, hopefully you remember that they were all congruent circles. Okay. Now, what is the area of the cross section? Well, it would just be pi r squared, right? The area of a circle would be the area of your cross section. Okay, pi r squared. So remember, the base and the height are the same because they are still circles, and they're the same congruent circle on top as it is on bottom. So it doesn't matter where we're looking at the cylinder. Okay, our base is going to be that circle, and it's the same throughout the cylinder if we took cross sections. So the volume of a cylinder is very similar, okay, to the volume of a prism. It's just the area of your base times the height. So in this case, big B is just pi r squared, okay, because it's a circle. For cylinders, our bases are circles. Okay, so I want you guys to just try a cylinder problem without doing the books problems. They're a little bit more complicated than we need for our first try. So what I'm going to do is I have this picture here on the right, and again, you might want to pause the video and draw it in for yourself. But I have a cylinder. It's showing you where the radius is and what the height is. Okay, find the volume of that cylinder. Okay, if you did it correctly, here's the answer, 3,769.91 inches cubed. And again, volume is always cubic units. So again, if we took the area of our circle, so 10 squared is 100 pi, okay, times that by the height. You just have to punch that in the calculator. So you could have left it in terms of pi if you wanted the exact answer. So 1,200 pi inches cubed. Okay, or punch it in a calculator to get the approximate volume. Okay. The last thing we're going to cover here is some problem solving things. So let's check out example A. It says the volume of a cylinder shown is 650 feet cubed and the diameter is 8 feet. What is the height of the cylinder? So we're going to use our formula here for the volume, pi r squared times the height, area of the base times our height. Okay, and they rearranged it first before plugging in numbers. I personally would probably plug in the values first and then solve for h, but we kind of can do things different ways. So I'm actually going to do A for you, and then I'm going to have you guys try B and C. Okay, so in A it says the volume of a cylinder is 220 centimeters cubed. So remember, volume is the area of the base times the height. Okay, or in this case, since area of bases are circle, I might actually use the circle formula instead. Pi r squared times the height. So we know volume is 220. So I'm going to set this equal. 220 is equal to, now our radius they said is 5. So in our formula, we need radius squared. So I'm just going to square 5. 5 squared is 25. So we'd have 25 pi times h. Now our goal is to get h by itself. I'm solving for the height. What's the height of the cylinder to the nearest tenth? Now remember, pi is just a number, So we can technically just divide this out in one step. Okay, 25 pi. And just plug that into a calculator. So if you plug 220, divide that by 25 pi, we should get this answer here, 2.8 centimeters. Okay. So I'm going to have you guys try B and C. I'm going to actually make this a little smaller so I don't cover up the problem. There's my work. 25 pi. There we go. Okay. I'm going to have to start with B because it's very similar to the one I just did. It says the volume of a cylinder is 90 meters cubed and the circumference of one of the bases is 27. Now, remember in our formula, you need to know what R is because you need R squared. So if they're giving you the circumference, okay, the circumference of the base is 27, figure out how you can get the radius from that, if you remember your circumference formulas, and then use that to find the height of the cylinder if the volume is 90. So you guys are going to try B right now. Okay, here's what you should have gotten for the answer. It's 1.55 meters. So for me personally, if I'm using circumference, I probably just would have done pi times diameter. So if the circumference was 27, I would have just divided the pi out to get the diameter of my circle. Okay, so what do we have? 27 divided by pi. Okay, is let's say 8.6. Okay, so that's my diameter. Okay, but remember, I need not that, I need the radius. So let's just divide that by 2. So that makes my radius about 8.3, or sorry, 4.3. Okay, so now I can use my formula for volume. We know it's 90 is equal to 4.3 squared pi times h. So we would just have to find 4.3 squared, divide that on both sides from 90, and that should give us 1.5 for our height. Okay, one last question here. It says the volume of a rectangular prism. So remember, for the volume for a prism, it's the area of the base times the height. Now they're saying it's a rectangular prism, so that means our base is a rectangle. So we're going to use that here in a second. So it says the width is 15 and the height is 4. What is the length of the prism? So go ahead and try and work this one out. See what you get for the length of the prism. Okay, here is the answer you should have gotten, which was 2 feet. Okay, so since we have big B would be the area of our base. Think of that as kind of length times width, right? Our volume, 120, has to be equal to basically length times width times height is how I would set this one up. Because length times width is the area of your base. Height would be the height of the prism. So we have 120 equal to 15 times 4 would be 60. Basically, we're going to have 60L. If you divide that out, you should get 2. Okay, so that was just using a little problem solving, using the formula and knowing how to manipulate the variables to kind of get what you want. Okay, so we will practice more tomorrow in class, but just remember, anytime you're trying to find the volume of a figure, it's the area of the base times the height.